Hello everybody. Today I'm going to tell you about the gradient of a scalar point function or a scalar field. As I have written here, consider a region R in a space where a scalar point function or a scalar field is defined. Let the value of scalar point function at point P, this is the point P, be phi, and at point Q, which is at a distance of dr from P, let at this point the value of the scalar field be phi plus d phi. Then the overall change in scalar field will be given by del phi at Q minus phi at P, difference between these 2 points, which is equal to phi plus d phi minus phi, as we have assumed here, which is equal to d phi. Now let us consider a path from P to A to B, B to Q. While moving from P to Q, we have to go through this part. We have assumed it. At P, the value of scalar function is phi. At A, it will be different. Let us see it. We see that the rate of change of variation of scalar point function along the path P to A to B, B to Q. Value of SPF at P is phi. We know it. Value of scalar point function at A, which is phi A, will be equal to the scalar point function at the point P plus the rate of change of scalar point function in the direction of x multiplied the length dx. The length dx is this length. The rate of change of scalar point function in the direction of x multiplied the length will give us the electric field and the scalar point function at this point. Similarly, the scalar point function at B is given as the sum of the scalar point function at A, which is this point, as it has changed from this to this. So at B we will have the value of the function A plus the rate of change of y component multiplied by dy. So the value of scalar point function at B will be phi A plus d phi A by dy into dy. This is the value of scalar point function at B. After solving it, you can see it. We have neglected some terms which are very small, and we get this term. It is easy, you can solve it. After that, we can see by the same procedure the value of scalar point function at Q will be equal to the value of scalar point function at B plus rate of change of the scalar field in the z direction. When we again elaborate it, we get these things, and summing all these up we get del phi is equal to this thing. Firstly we calculated the change in scalar point function is d phi. So d phi will be equal to this thing which we have got minus the first one. Here I have done the calculations. So d phi is equal to this. This is the first application of Taylor theorem, and thus we have got the change in scalar field function is equal to the rate of change of phi in z x direction plus y direction plus z direction. On writing it in this, we can write it in this form. We can see I dot I is equal to 1, so it will be same. This thing is known as del phi because this is del. This is a operator. It operates on phi, so it is del phi dot dr from this. So this was the gradient of a function, and I think you would have got what I wanted to say. If you have any queries, you can ask it in the comments. I will definitely answer it.